Okay students, next we are going to see about the next topic, that is nothing but the force. In our day to day life, we are using force. So every activity we are applying some amount of force. We are already having internal force and external force. Okay. So the object which can move or we have to do any activity, for that we have to apply some external force on the object, then only the object can move from one place to another place. Okay. So there are different types of forces. Okay. Here now we can see about the definition of force. So what is the definition of force? See, force is that which change or tends to change the state of rest or of uniform motion in a straight line. Okay. Already we saw about the Newton's first law of motion. The same concept I told you, the same definition of force, that is, force is that which change or tends to change the state of rest. Every object here that has mass m, every object that has, I already told you, every object that has mass m, when we are not applying any external force on the agencies or object, it doesn't move. It remains constant forever. Okay. When we apply an external force on the object, that external force, we are applying number of forces. Suppose for example, 50 Newton of force or 100 Newton of force, whatever it may be. So it is nothing but the magnitude. We are applying the magnitude or the force, we can say. When we are applying the external force on the object, some amount of force on the object can move in a straight line from one place to another place. It changes its position. It changes position. Okay, it changes its position from one place to another place. Some distance it is covered. That is nothing but displacement. The same amount of mass. It is moving with a uniform velocity. In what way or what amount of force we are applying, it is moved with some velocity. It moves with some velocity to change its position from one place to another place. That only the forces that will change or tends to change the state of rest or of uniform motion in a straight line. Okay. So what is the unit of force? Its unit is, force unit is Newton. Its unit is Newton. Or otherwise we can write that is nothing but R kg m s power minus 1, kg s power minus 1. For the force, the SI unit of force is, we can say the SI unit of force is Newton, or otherwise we can write kg m s power minus 1. How can we know that this kg m s power minus 1 for Newton or for force? That is, we know the formula for force formula, that is F equal to ma. F equal to ma. Here F is the force, here m is the mass, and a is acceleration. A is acceleration. So what is it? For mass, the unit of mass is kg. The unit of acceleration is nothing but ms power minus 2. Ms power minus 2. That's so, according to this formula F equal to ma, the unit of force is Newton, or otherwise we can write kg ms power minus 2. For mass m, for acceleration ms power minus 2. When we comparing this, that becomes the kg ms power minus 2. The SI unit of Newton is Newton or kg s power minus 2 in SI system, or in CGS system. This is for SI unit of force. SI unit of force. Then in CGS system, the force is nothing but, it is nothing but dyne. The unit of force in CGS system is nothing but dying. Okay. Here we saw about the definition of force. Okay, and this we can say its unit is Newton or kg ms per minus 2, or in CGS system it is nothing but dyne. Okay, it is a vector quantity. Force is a vector quantity. Force is a vector quantity. How it is a vector quantity? Because the force has both magnitude and direction. The force that has both magnitude and direction. See, magnitude, that is some amount of external force we are applying on the mass. The object is moving in a straight line with a direction. So I told you, suppose for example 100 Newton. It is nothing but the amount of external force, that is nothing but magnitude. It is moving with some velocity in a straight line. So that straight line, that the rectangle or the straight line, that shows the direction. Or otherwise, this arrow mark that denotes direction. So it is moving in a straight line. So the force that has both magnitude and direction. So it is called a vector quantity. Okay. It has types of forces. Okay. We saw that definition of force. Then we have types of force. Here we can see types of force. Okay. In this types of force, we can see first one, like parallel force. Like parallel force. Second one is unlike parallel force. Unlike parallel force. So it has two types of forces. One is like parallel force and another one is unlike parallel force. First we can see like parallel force. What is meant by like parallel force? When two equal forces when two or more equal forces or unequal forces, it has magnitude, equal or unequal magnitude. When two or more equal or unequal magnitude, both the forces are acting in a same direction. Both the forces are acting in a same direction. That is P force and then another one is Q force. Both forces are acting in a same direction. It may be varied whether the magnitude will be equal or unequal. Okay, suppose P and Q, if you see like this, if it is one equal or unequal. Okay, when two or more forces that is equal or unequal in magnitude, but both the forces are acting in a same direction, it is parallel to each other. Parallel to each other. It is nothing but like parallel force. It is nothing but like parallel force. When two or more equal in forces are equal in magnitude or unequal in magnitude, but both the forces are acting in the same direction. So that is nothing but parallel to each other. It is nothing but parallel to each other. So this we can say like parallel force. It is nothing but like parallel force. Okay. Then what is my unlike parallel force? This we can say unlike parallel force. Unlike parallel force. Here, when two or more forces are equal or unequal in magnitude, when two or more forces that is equal or unequal in magnitude, both the forces are acting in opposite direction. Both the forces. See now, this P force and then Q force. Okay, it is nothing but P force. It is nothing but Q force. Okay. Suppose for example, This is 50 Newton. It is 100 Newton or 75 Newton. Okay, so both the forces are acting in a opposite direction. It is parallel to each other. It is parallel to each other. It is called a unlike parallel force. It is called a unlike parallel force. Okay, like parallel force and a unlike parallel force. When two are more equal or unequal in magnitude, but both the forces are acting in the same direction, that is parallel to each other. That is called a like parallel force. Unlike parallel force, what is that? When two or more forces that is equal in magnitude or unequal in magnitude, but both the forces are acting in a opposite direction. Both the forces are acting in a opposite direction. So that is nothing but unbalanced force. Okay, this is types of force, and in this like parallel force and the unlike parallel force. Okay, now we can see balanced force and unbalanced force. In this, first one is balanced force, second one is unbalanced force. So what is the difference between balanced force and unbalanced force? So what is meant by balance? Balance means it is nothing but in equilibrium position. Okay, what is that? That is nothing but it is in a equilibrium position. When you are doing something, or if you are purchasing something in a market or in a vegetable shops or anything, both the scales are in a pans, both the scales are in a same direction. Okay, this is a scale needle. When if it is a mass that is 100 gram or 1 kg, 1000 gram, here the object which is kept in another pan, when it is both the sides are equal, it is in equilibrium position. So that is nothing but balanced force. Or otherwise, I already told you Newton first law of motion. For example, tug of war. Okay, the tug of war is nothing but what is that? Both the sides are in opposite direction. They are pulling the rope. Which side has the greater force and which side has the lesser force? Okay, so both the sides are having the same magnitude. What is that? That will be the balance. If one side is greater force, that is nothing but unbalanced force. The same way here, both the side it has same magnitude. It has both the side it has a same magnitude, so it is in equilibrium position. It is balanced, so that is nothing but balanced force. Unbalanced force. What is my unbalanced force? If it is one side, suppose if it is 1100 gram of magnitude and it has the object is very less, so here it has a greater force or greater in magnitude. Greater force or greater in magnitude. Here the vegetables is for example 900 gram. 900 gram. So it is a lesser in magnitude. So one side is greater and other side is lesser. So it is not in equilibrium position. It is not in a equilibrium position. So which side has a greater force? That side will be as a greater force. Okay, so that will not be a balance. So that we can say it is a unbalanced force. Okay, thank you. Okay students, next we are going to see about the next topic, that is nothing but resultant force. You saw that the force, definition of force, types of force, like parallel force, unlike parallel force, then balanced force and unbalanced force. Now resultant force. What is that resultant force? Sum of the individual forces are combined together or impact both all the forces are combining together, that we can say the total force or net force. For example, here it is a F1 force. Now it is F2 force. Now it is F3 force. So here it has F1 force, it has F2 force, it has F3 force. Okay. So what is it? The total force F equal to, that is F1 plus F2 plus F3. So when it is the total net force, it will be 0. A total momentum we can say it will be 0. Here the force, the total force or the net force, that is equal to sum of the individual force. The net force or the total force is equal to sum of the individual force. So that is the total force F equal to F1 plus F2 plus F3. So that is nothing but the resultant force. Otherwise here P is the one force and another one Q is the another force. That is said two forces are acting in a different direction. Then the third one, the line joining P and Q forces, that is nothing but R forces. Okay. So here R equal to P plus Q. R equal to P plus Q. So the net force equal to sum of the individual force. So that is nothing but R equal to P plus Q. So that is nothing but the resultant force. Some of the forces are acting in a different direction or this. Okay. Here, if the resultant force is not equal, it will not be 0. The resultant force will be is the net force. What is that? If the net force will be 0, then it will be in an equilibrium position. Okay. The net force will be 0. It is in equilibrium position. If the net force is not in equilibrium, it is not 0. So that is there nothing but the resultant force. Okay. Thank you.